Hello, this is a small demo for the visual processing unit of the robot Zenith. Right now I have a Raspberry Pi connected to a Raspberry Pi camera and a button over here, and this demo will be able to detect a component and tell the name of the component. So this is done by using an AI model which takes a picture of the component and processes it through the model and names the component. The final version should be able to name a component and also do all of this in real time, so no human input would be needed and it's completely hands free. And once the component is detected, the user gives a voice command conveying a certain instruction or a certain question, and the robot must be able to answer those questions by passing the named component and the question through a AI API like ChatGPT or Claude, and then give the answer as quickly as possible. But for now, since this is the first iteration, I've placed a button so that I can take individual pictures of components and test the accuracy of the AI model. It's not 100% accurate because it's the first iteration and it needs a little bit of fine tuning, but I think it works quite well. Let's get started with the demo. So right now I have a DC to DC buck converter. So this basically reduces the voltage of a certain DC power supply. It can be a battery or anything. So I want to place it in front of the camera, and it's being shown in the preview on the screen. And when I press the button, you could see it being processed, and it's being shown as the DC-DC buck converter, and that's correct. So next I'm going to take a servo motor, and I'll be placing the servo motor in front of the camera, and you could see it being displayed on the screen. And I'm going to press the button, and that's a servo motor. And next I'm going to be placing an Arduino. It's been shown on the screen, and I'm pressing the button. It's being processed, and that's an Arduino Mega. That's correct. And next I'm going to be placing a Raspberry Pi camera. I had an extra one laying around. I'll be placing it here, and I think I'll be having to hold it by hand, and I'm pressing the button right now, and that's being processed, and that's a camera module. So it's pretty accurate most of the time, but I think the accuracy could be increased much more, and it seems to have difficulty in detecting smaller components, and I think that could be solved by purchasing a better camera module. I think this will be extremely useful for makers, especially when they're having their hands busy with screwdrivers. And for instance, I had my hands with the oil of a motor because I was playing around with the lubricant of the motor, and I had to solve a critical issue in my Arduino, but my hands were oily and I didn't want to touch my keyboard. I didn't want to interact with my laptop, so I had to solve it by myself, and that took me like 30 minutes. But I think with a robot like this, that time could be cut down to like 10 minutes, and that will exponentially decrease the time taken for prototyping. And yeah, I think it'll be extremely helpful for anybody who is working with robotics and mechanical engineering and stuff like that. So hope it works out. And yeah, and also, since this is the first iteration, I've powered the Raspberry Pi directly via the AC power supply. But I think in the final version I'll be powering it via battery because I want the robot to be extremely mobile, and it should follow around the person who is doing stuff like around the home lab. And also it won't be connected to a monitor like this. The Raspberry Pi would be connected to its own display, which will be mounted onto the robot, and it should be a much smaller package as well. So let's see how it works out. Thank you.